In this lesson, we're going to be focusing on partial fractions. But before we go into calculations, let's first of all understand what partial fraction is. And we know that 1 over 3 plus 4 over 3 is equals to 5 over 3. Now, these two fractions, 1 over 3 and 4 over 3, cannot be made simpler than the form in which they are now. So they are said to be the partial fractions of this fraction 5 over 3. On the other hand, this fraction 5 over 3 is said to be the compound fraction of these two partial fractions 1 over 3 and 4 over 3. Now, suppose we want to start with a compound fraction, for example 5 over 3. How do you perform the reverse process of transforming this compound fraction into the sum of two partial fractions, just like we have here 1 over 3 plus 4 over 3. Now, this process is what is called resolution into partial fractions. Now, let's dive into calculations. Partial fractions generally fall into 4 categories. The first one are those that have non-repeated factors at the denominator. For example, 7x plus 19 over x plus 1 multiplied by x plus 5. Now, if you take a clear look at this compound fraction, you see that they have two factors, and these are non-repeated factors. You understand? These are two linear factors. X plus 1 is not the same as x plus 5. That's what I mean by non-repeated factors at the denominator. And then to solve this kind of partial fraction, we're going to equate it to a sum of constants, which I'll call a, over the first factor, which is x plus 1, then plus another constant, which I'll call b, over the second factor, x plus 5. Now, the reason why we are choosing only two constants is because if you FOIL these two factors, that's if you expand it, you're going to have x squared. And so because of the presence of this square, these two here, we're going to have only two constants. So how do you determine the value of a and b? To determine the value of a and b, we're going to find the LCM of x plus 1 and x plus 5, and then multiply each of these terms here with the LCM. But then it happens that the LCM of x plus 1 and x plus 5 is equals to this. So we're going to multiply every term here by x plus 1 multiplied by x plus 5. So we're going to have 7x plus 19 over x plus 1 multiplied by x plus 5. Then let's multiply everything by the LCM, which is x plus 1, x plus 5. Now this is equals to a over x plus 1, then multiplied by the LCM, which is x plus 1 multiplied by x plus 5, b over x plus 5. Let's multiply everything by the LCM, which is x plus 1 multiplied by x plus 5. On the left hand side, this and this will cancel. The right hand side, x plus 1 and x plus 1 will cancel. X plus 5 and x plus 5 will cancel. We'll be left with 7x plus 19 is equals to a multiplied by x plus 5 plus b multiplied by x plus 1. So we have 7x plus 19 is equals to, let's open this parenthesis, a times x is equals to ax plus a times 5 is equals to 5a, then plus b times x is equals to bx plus b times 1 is equals to b. So we have 7x plus 19 is equals to, let's collect like terms, those that have x and then the constants. So we have ax plus bx then plus 5a plus b. So we have 7x plus 19 is equals to, x and x are common here, so let's bring it out. We are going to have a plus b multiplied by x, then plus 5a plus b. Now this method I'm using now is called method of comparing coefficients. So I'm going to be comparing coefficients of x at the left hand side to the coefficients of x at the right hand side, and then the constants at the left hand side to the constants at the right hand side. So when we do that, we're going to have that 7 is equals to a plus b, and then 19 is equals to 5a plus b. Let's call this equation I and this equation II. So we're going to solve these two equations simultaneously, and so let's subtract equation II from equation I. 7 minus 19 is equals to minus 12. Then this is equals to a minus 5a is equals to minus 4a. Then b minus plus is minus, b minus b is equals to 0. So let's divide both sides by negative 4. So this and this will cancel, negative and negative will cancel. 4 divided by 4 is 1, 12 divided by 4 is 3. So we have that the value of our a is equals to 3. Now from equation I, let's find the value of b by substituting a to be 3. So we're going to have 7 equals to a is 3 plus b. So let's subtract 3 from both sides. 7 minus 3 is equals to 4. 3 minus 3 is 0. Then we have 0 plus b is equals to b. So this implies that b is equals to 4. So a is equals to 3 and b is equals to 4. And then the final answer to this question is that 7x plus 19 divided by x plus 1 multiplied by x plus 3 is equals to, now a is equals to 3, then over x plus 1 plus b is equals to 4, then over x plus 5. So these two terms are the partial fraction of this compound fraction. So let's solve the second example in this category. So the second question is 2x plus 3 over x plus 1 multiplied by x plus 4. Now just like what we did earlier, we're going to equate this to a divided by x plus 1 plus b divided by x plus 4. Now I want you to pause this video and try this question. When you're done solving it, you play it and see if you got the answer. Now the first we're going to do is to find the LCM of these two factors and then multiply everything in this equation with that fraction, with that LCM, just like what we did earlier. So we have 2x plus 3 divided by x plus 1 multiplied by x plus 4, then multiplied by the LCM, which is also equals to this. So I have x plus 1 multiplied by x plus 4, then this is equals to a over x plus 1, then multiplied by x plus 1 x plus 4, then plus b over x plus 4, then multiplied by x plus 1 x plus 4. Now all of this and this will cancel. X plus 1 and x plus 1 will cancel. x plus 4 and x plus 4 will cancel. We're going to be left with 2x plus 3 is equal to a multiplied by x plus 4 plus b multiplied by x plus 1. Now, in the previous example I solved, I used method of comparing coefficients. In this one, I'm going to use another method which is called cover-up method. In this cover-up method, we try to eliminate any of these constants, which is a or b. Alright, so how do we do it? How do we eliminate either a or b? Now, to eliminate a, what we're going to do is to make x to be equals to negative 4. Now, if you set x to be negative 4, if you substitute negative 4 here, you're going to get 0. Negative 4 plus 4 is 0, which will automatically eliminate a. Then it will allow you to find the value of b. So let's do that. When x is equals to negative 4, I will have 2 multiplied by negative 4 plus 3 equals to a multiplied by negative 4 plus 4, then plus b multiplied by negative 4 plus 1. Now, 2 times negative 4 is negative 8. Negative 8 plus 5, that is 5 minus 8, is equals to minus 5. Then this is going to be equals to, now this has cancelled, minus 4 plus 4 is 0. Now, minus 4 plus 1 is equals to minus 3. So this is going to be equals to minus 3 multiplied by b. Now let's divide both sides by minus 3. So this and this will cancel. These two negative signs will cancel. We're going to have that our b is equals to 5 over 3. Now, using the same cover-up method to find the value of a, let's set x to be equals to negative 1 so that we eliminate this b here now. Let me make some space here. Now, if we set x to be negative 1, we're going to have 2 multiplied by negative 1 plus 3 equals to a multiplied by negative 1 plus 4, then plus b multiplied by negative 1 plus 1. Now, 2 times minus 1 is minus 2. 3 minus 2 is equals to 1, then equals to minus 1 plus 4 is equals to 3. So we have 3a. Now, minus 1 plus 1 is 0. 0 times b is 0. This one is gone. So let's divide both sides by 3. This and this will cancel, and then this implies that a is equals to 1 over 3. So let me just write it here. A is equals to 1 over 3. So the final answer is that 2x plus 3 divided by x plus 1 multiplied by x plus 4 is going to be equals to, now this a is 1 over 3. We have 1 over 3 divided by x plus 1, then plus b is 5 over 3. We have 5 over 3 divided by x plus 4. Now, there's another way to express this. Let's bring this 3 to the denominator here, so that we're going to have 1 over 3 multiplied by x plus 1, then plus 5 over 3 multiplied by x plus 4. There's also another way to express this answer. Remember, you have 3 here and we have 3 here. So let's bring out 1 over 3. If we bring out 1 over 3, we're going to have here, we'll be left with 1 over x plus 1, then plus, on this side, we're going to be left with 5 over x plus 4. And so this is also the answer to this question. So either you go with this, this, or this. So this is the answer to this question. Let's now go into the second category. Now, the second category are those partial fractions that has nonlinear factors that are not repeated. For example, if you have 3x plus 2 divided by x plus 1 multiplied by s squared plus x plus 2. Now, they can have one linear factor and one non-linear factor, or they can have, for example, 3x plus 2 over, they can have two non-linear factors such as s squared plus 1 multiplied by s squared plus x plus 2. So in which case, these two fall into that category of non-linear factors that are not repeated. It can be a combination of linear and non-linear, or both non-linear. Now we're going to solve these two questions. Let's start with the first one. So anytime you see this kind of question in partial fractions where you have one linear factor and one non-linear factor, we are going to equate this to be a divided by the non-linear factor, which is x plus 1, then plus, for this non-linear factor, remember, if you expand these two factors, if you expand them, you're going to have s raised to the power 3. So the degree of the answer you get after expanding these two factors is going to be equal to 3. And so because there are 3, we're going to have 3 constants, you get. So how are we going to represent that 3 constants here? Now, if you look at this term here, you see that we have x squared. So if we want to represent this factor, we're going to write bx plus c, then divided by s squared plus x plus 2. Now, if you have x squared here, you start with bx, that is, you remove 1 from these two, it will be only x, that is this x here. Assuming I have sq plus s squared plus 1, what I'm going to write, instead of writing bx plus t, I will remove 1 from this 3, that is, subtract 1 from the 3, it will be s squared. You start with ax squared plus bx plus c. Do you understand? So whichever degree of polynomial you have, just remove 1 from that degree, and then in that order you write the expression for it. For example, if you have x raised to the power 4 plus some other terms here, you're going to write ax raised to the power 3 plus bx squared plus cx plus d, just in this order. That's how you're going to represent them. So let me just write this again. We have 3s plus 2 divided by x plus 1 multiplied by s squared plus x plus 2. Then this is equals to a over x plus 1 plus bx plus c over s squared plus x plus 2. Now, how do you determine the value of a, b, and c? How can we do that? Okay, just like we did earlier, we're going to find the LCM of x plus 1 and s squared plus x plus 1. But then it turned out that this also is their LCM. So we're going to have 3x plus 2 divided by x plus 1 multiplied by s squared plus x plus 2. Now, instead of me to multiply this by the LCM again, it's going to occupy a lot of space. Let me just, do the normal thing we know how to do. So let me just write the LCM here. X plus 1, s squared plus x plus 2. So we're going to have x plus 1, s squared plus x plus 2 divided by x plus 1. We're going to be left with s squared plus x plus 2. Now this times a is going to be equals to a multiplied by s squared plus x plus 2. So you have plus all of this divided by this. We're going to be left with bx plus c multiplied by x plus 1. Alright, so all of this and all of this will cancel because they are equal. So we're going to be left with only those that appeared at the numerator. So we're going to be left with 3x plus 2 equals to x squared plus x plus 2 plus bx plus c. Please, this is in brackets, so multiply by x plus 1. Where you have 3x plus 2 is equals to, we're going to solve this using the method of comparing coefficients and also a method of cover up, so the two of them can work here. So this is equals to, let's multiply out. A times x squared is equals to a x squared plus a times x is equals to ax plus a times 2 is equals to 2a, then plus bx times x is equals to bx squared, then bx times 1 is equals to plus bx. Now c times x is equals to plus cx, and c times 1 is equals to plus c. So I have 3x plus 2 is equals to, actually this is now equivalent to, alright. So let's collect like terms based on the degree of the x. So we have ax squared plus bx squared, then plus we have ax plus bx, so this is ax plus bx, and then we have, okay, we also have plus cx, which is this, then the constants, which are 2a plus c. Alright, so we have plus 2a plus c. So we have 3x plus 2 is equivalent to, let's then factor out. So we have a plus b multiplied by x squared plus a plus b plus c multiplied by x, then plus 2a plus c. So let's compare the coefficients. Now we have x squared here, we don't have any x squared here, so we're going to equate it to 0. So let's equate a plus b to 0. We're going to have a plus b is equals to 0. Then let's call this equation I. Now what about x? Okay, we have x here, we have x here, so we're going to equate a plus b plus c to 3. So we have a plus b plus c is equals to 3. Then let's call this equation I. And then lastly we equate this constant 2a plus c to 2. So you have 2a plus c is equals to 2. Let's call this equation I. Now if you look at these three equations, we can solve them simultaneously. Alright, yes, we can solve them simultaneously, but then there's a more simpler way to solve this. Let's use cover up method and find the value of a first. Now notice that if we set x to be -1, this whole term here is going to be eliminated, and then it will help us to now find the value of a. So let's do that. Let's set x to be -1. So from the left hand side we have that 3 multiplied by -1 plus 2 is equals to a multiplied by we have -1 square plus -1 plus 2. Now -1 here, all of this is already 0, so let me not just write them out. 3 times -1 is -3 plus 2 is equals to a multiplied by -1 square is equals to 1, plus times minus is -1 plus 2. So 1 minus 1 is 0, we'll be left with only 2. And then 2 minus 3, which is something as -3 plus 2 is equals to -1. So this is equals to a times 2 is the same thing as 2a. So from here, let's divide both sides by 2. This and this will cancel. We'll see that our a is equals to negative 1 over 2. So we have that a is equals to negative 1 over 2. Now from equation I, let's substitute a to be negative 1 over 2. Before then, let's make b subject to the formula. So b is equals to minus a. Then b is equals to minus, our a is minus 1 over 2. Minus times minus is plus. So b is equals to 1 over 2. So we have that b here is equals to 1 over 2. Now, having gotten the value of a and b, let's use equation I to find the value of c, because we already have a. So let's make c the subject of formula. So if you do it, you see that c is equals to 2 minus 2a. Alright, so c is equals to 2 minus 2, a is equals to minus half. So c is equals to 2 minus times minus is plus. This and this will cancel to give us 1. Alright, so c is equals to 2 plus 1 is 3. So this is the value of c. Now this final answer to our question. No, I've wiped out the original equation. So we can write the final answer to this question as 3x plus 2 divided by x plus 1 multiplied by x squared plus x plus 2 is equals to, now our a is equals to minus 1 over 2. So this is equals to minus 1 over 2 multiplied by x plus 1, then plus bx plus c. B is half x plus, and then c is 3 divided by x squared plus x plus 2. Now this can also be expressed as minus 1 over 2 multiplied by x plus 1, then plus, we can factor out 1 over 2. We have 1 over 2. Then on the numerator, we'll be left with x plus. Now this 3 is going to be 6, because 6 divided by 2 is equals to 3. Then divided by x squared plus x plus 2. So this is also the answer to this question. So whichever form we want to leave it is acceptable. Let's solve the second question in this category. And the second question is, we are given 3x plus 2x minus 1 divided by x squared plus 1 multiplied by 2x squared plus 3x plus 1. So I ask to resolve this into partial fractions. I want you to pause this video and solve this question. When you are done solving it, you unpause it and see the solution. We're going to express this as, since we have x squared here, we start with ax, then plus b divided by, we have x squared plus 1, then plus, since we also have square here, you start with, we have ab, then you have c x plus d divided by 2x squared plus 3x plus 1. So let's multiply everything here by the LCM. So just like we have been doing before, the LCM, sorry, this is one here. The LCM is just simply this whole stuff here. So let me write 3x plus 2x minus 1 divided by s square plus 1 multiplied by 2s square plus x plus, no, this is 3x plus 3x plus 1, then equals to, now the LCM is s square plus 1, 2s square plus 3x plus 1. Now all of these divided by this, we're going to be left with this part. Alright, now this part multiplied by this is what I'm going to write next, and it's going to be equals to ax plus b multiplied by this part, which is 2x square plus 3x plus 1, then plus all of these divided by this, will be left with this. Alright, then this times this is what I will write next, which is equals to cx plus d multiplied by s square plus 1. So this and this will cancel. We'll be left with 3x plus 2x minus 1 is equals to, this is equivalent to, now we have a x plus b multiplied by 2s square plus 3x plus 1, then plus cx plus d multiplied by s square plus 1. So how do we determine the value of a, b, and c here? This is going to be a long process. Alright, so but then let's FOIL. So we have 3x plus 2x minus 1 is equivalent to, we have, let's multiply out, ax times 2x square is equals to 2ax cube, then ax times 3x is equals to 3ax square plus ax times 1 is equals to ax plus b times 2x square is equals to 2bx square. B times 3x is equals to plus 3bx. B times 1 is equals to b, then plus cx times x square is equals to cs cube. Cx times 1 is equals to plus cx, then have plus d times x square is equals to dx square, then plus d times 1 is equals to d. So we have that 3x plus 2x minus 1 is equivalent to, let's collect like terms. So we have 2axq and csq. So we have 2as cube plus cs cube. Now for those with s square, we have 3as square, 2bx square, and ds square. So we have plus 3as square plus 2bx square plus dx square. Now for those with x only, we have ax, 3bx, and cx. So we have plus ax plus 3dx, then plus cx. And then for constants, I think we have only two constants, which is b and d. So let me just write it here, plus b plus d. Well, I've run out of space. Let me write all of this. So you have 3x plus 2x minus 1 is equivalent to, so we have s square, sq rather, and sq. So let's factor it out. So we have 2a plus c, then s cube, then plus, let's factor out s square here. So we have 3a plus 2b plus d, then we have x square here, then plus those with x alone, x and x. Let's factor it out. Then we have a plus 3b, sorry, this is 3b plus c, then multiply by x, then plus the constant, which is b plus d, then plus b plus d. Now let's equal the coefficients. So sq is here, we don't have sq here, so you have that 2a plus c is going to be equal to 0. Let's call this equation I. And then for x square, we have that 3a plus 2b plus d is equals to, this is s square here, so this is equals to 3. Let's call this equation II. And then for x, we have that a plus 3b plus c is equals to, x here is 2. Let's call this equation III, and then the constant b plus d is equals to -1. And then that is going to be our equation 4. So this will form our equation 4, which is IV. So from equation I, let's make C the subject of formula. If you do it, you see that C is equals to minus 2a. Then let's call this equation V. And also from equation IV, let's make D the subject of formula. Then if you do that, you see that D is equals to minus 1 minus b. Now let's call this equation VI, which is 6. So we are going to substitute equation V and VI into equation II and III. So anywhere you see C or D in these two equations, you substitute these terms. So for equation II, we have 3a plus 2b plus d, but d here is minus 1 minus b, right? Then this is equals to 3. So you have 3a plus 2, rather 2b minus b is equals to b. So b, then minus 1 is equals to 3. Of that 3a plus b, then is equals to 3 plus 1 is 4. So this will be our equation VI. So coming to this equation III, we have a plus 3b plus, now c is minus 2a, plus minus, let me just write minus 2a, then is equals to 2. Where am I going to wipe? So you have a minus 2a is equals to minus a, then plus 3b equals to 2. Now let's multiply everything out here by -1 so that we don't have negative a here. Minus times minus is plus a, then -1 times plus 3b is minus 3b equals to -1 times 2 is equals to -2. So this will form our equation VII. So we're going to solve these two equations now simultaneously. So from 4 equations to 2 equations. So let's solve that 2 equations simultaneously. Now, how are we going to solve this? We can solve this using elimination method. Let's multiply equation VII by 3 so that we have 3a here and then eliminate it. So if you do that, we are going to have 3 times a is equals to 3a minus 3 times 3 is 9b is equals to 3 times -2 is -6. Let's call this equation VII. We're going to subtract equation VII from equation VI. So it's going to be like this: 3a minus 3a is equals to 0. B minus times minus is plus. B plus 9b is equals to 10b equals to, now 4 minus times minus is plus. 4 plus 6 is equals to 10. So let's divide both sides by 10. So b is equals to 10 divided by 10 is 1. So let me write it here that b is equals to 1. You know what? I shouldn't have erased those equations I formed. Alright, I have them here. So from that equation, we have that 2a plus c is equals to 0. We also have that b plus d is equals to -1. That is our equation IV. So b plus d is equals to -1. That's equation IV in those equations I formed. So since we've found the value of b, let's substitute b to be 1 here. So we have 1 plus d is equals to -1. Now d is going to be equals to -1 minus 1. We have that d is equals to -2. So let me write it here that d is equals to -2. Now from equation II, we have that 3a plus 2b plus d is equals to 3. And we've gotten the value of b and d. So let's substitute them into this equation. We have 3a plus 2b is 1 plus d is -2. This is equals to 3. We have 3a, 2 times 1 is 2. 2 plus minus is minus, 2 minus 2 is 0. So this is going to be equals to 3. If you divide both sides by 3, we have that a is equals to 1. Now we have gotten the value of a, b, and d. It remains equation c. So let's use equation I and find equation c. Equation I says that 2a plus c is equals to 0. So our a is equals to 1. So 2 times 1 plus c is equals to 0. 2 times 1 is 2 plus c is equals to 0. And so c is equals to -2. So we have that c here is equals to -2. So the final answer here is that the partial fractions of 3x plus 2x minus 1 divided by s squared plus 1 multiplied by 2x squared plus 3x plus 1 is equals to a is 1, which is something as 1x is something as x. So let me just write, or rather, is equals to a is 1, so you have 1x, even though 1x is something as x, then plus b is 1 over x squared plus 1, then plus c is negative 2x plus d is negative 2 over 2x squared plus 3x plus 1. So the final answer is x plus 1 divided by x squared plus 1, then minus 2x plus 2 divided by 2x squared plus 3x plus 1. So this is the answer to this question. Now for the third category, these are partial fractions that have repeated factors at the denominator. For example, x squared plus 3x plus 1 over x squared multiplied by x plus 3 squared. Now if you take a look at these two factors, x squared and x plus 3 all squared, we see that x squared can be simplified as x times x, and then x plus 3 square all square can be broken down as x plus 3 multiplied by x plus 3. So this is the first appearance, this is the second appearance. First appearance of this factor, second appearance. So they both are repeated factors. So just know that anytime a factor appeared twice, thrice, or 4 times, or 5 times, then that factor is a repeated factor. Now how do we express this to be in partial fraction? So this is a over, you write the simplest form of it, x, then plus b over the repeated form, which is x squared. So the same thing is applicable here. This is c over x plus 3 plus d over the repeated factor, which is x plus 3 all squared. So we have x squared plus 3x plus 1 over x squared multiplied by x plus 3 all squared, and this is equals to, we're going to find the LCM of x squared, x plus 3 and x plus 3 all squared. The LCM is just x squared multiplied by x plus 3 all squared. So we have x squared here and x plus 3 all squared. Now x squared multiplied by x plus 3 all squared divided by x. This x, we cancel one of these x here. We'll be left with x into x plus 3 all squared. Now this multiplied by a is what I'm going to write here. It's just going to be a multiplied by this thing I'm wiping out now. So it's going to be a multiplied by x into x plus 3 all squared. So we have plus. Now the whole of this divided by this, we're going to be left with only x plus 3 all squared. So x plus 3 all squared multiplied by b, we're going to have b multiplied by x plus 3 all squared. So we have plus the whole of x squared multiplied by x plus 3 squared divided by x plus 3. Now one of this x plus 3 will cancel, then we'll be left with only x squared multiplied by x plus 3. Now x squared multiplied by x plus 3 times c is what I'm going to write next here. So I'm going to write c multiplied by x squared multiplied by x plus 3. Now let me write plus d here. Now the whole of this divided by x plus 3 square. x plus 3 square will cancel, then we'll be left with only s square. Write down s squared times d is what I'm going to write here as dx squared. Now this and this will cancel, we'll be left with s squared plus 3x plus 1 is equivalent to, we have ax multiplied by x plus 3 all squared plus b multiplied by x plus 3 all squared plus c multiplied by s squared multiplied by x plus 3 then plus dx squared. So we're going to have s squared plus 3x plus 1 is equivalent to ax multiplied by, let's open this, or rather let's expand this factor here. So s squared is going to be s squared then plus 2 times x times 3 is equals to 6x plus 3 squared is equals to 9, then plus b multiplied by the same thing, which is s squared plus 6x plus 9, then plus c s squared multiplied by x plus 3 plus dx squared. So we're going to have s squared plus 3x plus 1 is equivalent to, let's multiply out, ax times x squared is equals to as cube plus ax times 6x is equals to 6ax squared. Sorry, this is x squared plus ax times 9 is equals to 9ax plus, we're done with this, b times x squared is equals to bx squared plus b times 6x is equals to 6bx. We have 6bx then plus b times 9 is equals to 9b plus cs squared times x is equals to cs cube plus cs squared times 3 is equals to 3cx squared plus dx squared. I have dx squared. So we have x squared plus 3x plus 1 is equivalent to, so let's collect like terms. We have as cube plus cs cube. So we're going to write it as, we have a plus c s cube plus, we have 6as squared plus bx squared plus 3cx squared plus dx squared. So this is going to be equals to 6a plus b plus 3c plus d then x squared plus, now our x is only 2, 9a plus 6b. I have 9a plus 6b x then plus 9b, the constants, plus 9b. So let's equate coefficients. If you look at the left hand side of this equation, you see that we don't have SQ, or rather I can write this as 0 S cube plus D, so that I'm going to equate A plus C to 0. So if we do that, we have that A plus C is equals to 0. Let this be our equation 1. And then for x squared, we have that 6a plus b plus 3c plus d is equals to 1, which is the coefficient of x squared. Now let's call this equation 2. And then for coefficient of x, we have 9a plus 6b. Then this is equals to 3, which is the coefficient of x here. Then let's call this equation 3. Then lastly, we have 9b, the only constant, is equals to 1 here. Now let this be our equation 4. Now it's very obvious from equation 4, we have that b is equals to 1 over 9. That's if you divide both sides by 9. You have that b is equals to 1 over 9. Now, from this equation I wrote down here, we can find the value of d by setting x to be -3. Alright, so if we set x to be -3 here, we have -3 plus 3 will be equals to 0, and then all of this will cancel. Before I expand this, we have x plus 3 all squared. So if we set x to be -3 here, everything here will be equals to 0. 0 times b will be equals to 0. Also, this one, before I expand it, it is equals to x plus 3 all squared. If we set x to be -3 here, everything here will be 0, because -3 plus 3 is 0. 0 times everything here, it will be 0. So we'll be left with only dx squared and the left hand side of this equation. So if we set x to be -3, we're going to have -3 all squared plus 3 multiplied by -3 plus 1 equals to d multiplied by -3 all squared. -3 squared is equals to 9, plus 3 times -3 is equals to -9, plus 1 equals to -3 squared is equals to 9 multiplied by d. 9 minus 9 is 0. We have 1 is equals to 9d. If we divide both sides by 9, we see that d is equals to 1 over 9. So from here we have that d is equals to 1 over 9. Now, having found the value of b, let's use equation 3 and find the value of a. 9a plus 6b equals to 3. So we have 9a plus 6b is 1 over 9. This is equals to 3. So 9a plus, we have 6 over 9. But we know that 6 over 9, 3 into 6 is 2. 3 into 9 is 3. So this is equals to 2 over 3. So we have plus 2 over 3 is equals to 3. So 9a is equals to 3 minus 2 over 3, which is equals to, now 3 can be written as 9 over 3, right? And 9 over 3 minus 2 over 3 is equals to 7 over 3. So I have that 9a is equals to 7 over 3. Let's divide both sides by 9. Now 9 and 9 will cancel, and a will be equals to 7 over 3 times 9 is 27. So 7 over 27, that will be the value of a. So a will be equals to 7 over 27. Now to find the value of c, let's use equation 1, which says that a plus c is equals to 0. Now c is equals to minus a, and then our a is equals to minus 7 over 27. So this means that c is equals to minus 7 over 27. Now finally we have that the partial fraction of x squared plus 3x plus 1 divided by x squared multiplied by x plus 3 all squared is equals to a is 7 over 27. We have 7 over 27 over x plus b is 1 over 9. We have 1 over 9 over x squared plus c is minus 7 over 27. We have minus 7 over 27 divided by x plus 3 plus d is 1 over 9. 1 over 9 over x plus 3 all squared. And then finally this is equals to 7 over 27x plus 1 over 9x squared plus, or rather this is minus 7 over 27x plus 3 then plus 1 over 9 multiplied by x plus 3 squared. So this is the partial fraction of this compound fraction. Lastly, let's discuss the fourth category, which involves improper fraction. So this is where the degree of the numerator is either equal to or greater than the degree of the numerator. So for example, if you have 2x squared plus 3x plus 10 divided by x plus 1 multiplied by x plus 2. So first of all, let's expand this denominator. X times x is equals to x squared plus x times 2 is equals to 2x plus 1 times x is equals to plus 1 times 2 is equals to 2. So I have x squared plus 2x plus x is equals to 3x plus 2. So this is equals to 2x squared plus 3x plus 10 divided by x squared plus 3x plus 2. Now notice that the degree of the polynomial at the numerator is equals to the degree of the polynomial at the denominator. Anytime you are given a compound fraction to resolve into partial fraction, and you notice that the degree of the numerator is either greater than or equal to that of the denominator, the first thing we are going to do is to divide the numerator by the denominator. So let's do that. So we have x squared plus 3x plus 2. Then here we have 2x squared plus 3x plus 10. Now 2x squared divided by x squared is equals to 2. 2 times x squared is 2x squared. Then 2 times plus 3x is plus 6x. 2 times plus 2 is equals to 4. Now let's subtract. 2x squared minus 2x squared is equals to 0. Now minus times plus is minus. 3x minus 6x is equals to minus 3x. Minus times plus is minus. 10 minus 4 is equals to 6. Now we're going to have 2x squared plus 3x plus 10 divided by x plus 1 multiplied by x plus 2, that this is going to be equals to 2, which is this quotient, plus the remainder, which is minus 3x plus 6 divided by the divisor, x squared plus 3x plus 2. But note that this is the factorized form of this divisor. Alright, so we're going to resolve this now into partial fraction, and when we get the answer we add 2 to it. So let's start. So we have minus 3x plus 6 divided by, if you factorize this, we are going to get this. So we have x plus 1, x plus 2. Now this is equals to, this partial fraction fall into the first category when you have non-repeated linear factors at the denominator. And to express it into partial fraction, we have a over x plus 1 plus b over x plus 2. So the sum of x plus 1 and x plus 2 is equals to x plus 1 multiplied by x plus 2. Then we are going to multiply each term in this equation by the LCM. So we're going to have minus 3x plus 6 over x plus 1 multiplied by x plus 2. Then this will be multiplied by x plus 1, x plus 2, and this is equals to a over x plus 1, then multiplied by x plus 1, x plus 2, then plus b over x plus 2 multiplied by x plus 1, x plus 2. So at the left hand side, this one and this one will cancel. Then at the right hand side, x plus 1 and x plus 1 will cancel. X plus 2 and x plus 2 will cancel. We're going to be left with minus 3x plus 6 is equivalent to a multiplied by x plus 2, then plus b multiplied by x plus 1. So to find the value of a, let's set x to be -1. If x is equal to -1, this b is going to be eliminated because -1 plus 1 is equals to 0. So this is going to be eliminated. So if we set x to be -1, we're going to have minus 3 into -1 plus 6 is equals to a multiplied by -1 plus 2. This one will be equals to 0. Minus 3 times minus 1 is 3 plus 6 is equals to minus 1 plus 2 is 1. 1 times 6 is a. So 3 plus 6 is equals to 9. Then we have that a is equals to 9. Now to find the value of b, let's set x to be equals to -2. If x is -2, then -2 plus 2 is 0. this a is going to cancel. Then we'll be left with minus 3 multiplied by negative 2 plus 6 is equals to b multiplied by negative 2 plus 1. Minus 3 times minus 2 is equals to 6 plus 6 is equals to minus 2 plus 1 is minus 1. Minus 1 times b is equals to minus b. So 6 plus 6 is equals to 12 equals to minus b. So we have that our b is equals to minus 12. Now the final answer to this question is that the partial fraction of 2x squared plus 3x plus 10 divided by x plus 1 multiplied by x plus 2 is equal to 2 plus a is equals to 9 over x plus 1, then plus b is negative 12 over x plus 2. So this is equals to 2 plus 9 over x plus 1 minus 12 over x plus 2. Thank you for watching. This is the end of the lesson on resolution into partial fractions. I hope this really helps. Share this with your friends, like this video, drop your comments, and don't forget to subscribe to my YouTube channel. Enjoy the rest of your day.